This goes over the practice before test, which was a Desmos activity that I asked you to do. Being able to do these following problems is really going to help you prepare well for the Unit 4 assessment. You will see a lot of very similar types of problems on the actual assessment. So let's get started. So you see a graph here, and it shows the journey of two snails. So the very first thing I want you to pay attention to and note is that, again, we have time being measured in seconds, right, on the bottom, and we have the position of the snail in centimeters, okay? So let's just kind of look at reading the graph first before we look over here about the choices that I need to select. So we're going to note that one snail started right here at 0. The other snail started at 20 centimeters. So that's just something to note. I also know that they're both going up. Both lines are going up. Okay, so that's good. That means it's positive. All right, so the other thing I want you to note is right here, they crisscross, right? The graph crisscrosses. So this means that the snail at A started out here and at some point overtook, meaning got ahead of snail B. That's what it means. The other thing I want you to remember is, remember when we talked about steepness? So when I have a steeper line versus a line like this, remember this line means it's hovering, it's not moving. Remember when it's just kind of going along, remember the drone? It's not moving, it's just kind of stationary, but time still ticks. And then the steeper your line, the faster you're going. All right, so what I'm going to do is, now that we've done that, I'm going to stop the video, erase everything, and then we'll look at the relationships that we need to apply. All right, so we're supposed to choose the choices that best the relationships between the two snails. So choose the choices that best the relationship, that best match the relationship. And we're supposed to choose all that apply. So that implies, that kind of gives you a hint that there's more than one. All right, so let's just again look at the graph. I know that A is steeper. So if A is steeper right off the bat, I know that A is moving faster. So snail A travels faster, or sorry, I'm not even reading that right. It says snail A travels farther than snail B. Farther. All right, so let's take a look at the very end. Let's take a look at the very end. So, how far did snail A travel? So right here, so snail A traveled 85 centimeters. How far did snail B travel? Let's go here. About 50, between 50 and 55. So let's just say approximately 55. All right, so who traveled farther? Well, we can see from the graph that A travels farther. All right, the next one says the speed of snail A is greater. So remember what I said, the steeper line means faster. So A, definitely, snail A has got a steeper line, so most definitely that works. All right, so we automatically, because snail A speed is greater, we can cross that one out. All right, so then it says at approximately 4 seconds, the snails are traveling at the same speed. So what I'm going to do is I'm going to go down and I'm going to change my color and I'm going to go to 4 seconds right here. I'm going to go up and I want to know, are they traveling at the same speed? Well, I just want you to think about, remember, speed is distance over time. So take a look at the speed at that point right here, this line. They're not traveling at the same speed. The lines are at different slopes, at different inclines. All right, so let's look at the next one. So I'm going to mark that one no. At approximately 4 seconds, the snails have traveled the same distance. So what I'm going to do is, see the 4 here that I drew in blue, and now I'm going to take this and I'm going to go over and I'm going to say, yeah, at 4 seconds, how far have they traveled? They've traveled 35 centimeters. So this is definitely true. All right, so the next question asks, snail A starts 20 centimeters ahead of snail B. So remember when I went over at the beginning, we talked about just what the graph was showing us? Well, take a look. Down here, the brown line that I've just drawn is snail A. Take a look. Where did they start? They started at 0. They didn't start 20 centimeters ahead of snail B. It was snail B that started that. So this is not true. So I cannot select that. All right. So if you would have selected those 3 or you weren't sure, now I've explained why each one of those options was true. All right. Moving on to the next slide. All right. Question number 2 says that we've got this function P that gives the number of people who ordered a vegetarian lunch D days after the new year. Which statement represents the meaning of P of 215 is equal to 89? All right, so I just want you to go back to the basics. What do you remember? P is the name of the function. So P of something equals something. All right, so number of people gives the number of people, P. So P is the output. It's the name of the function. All right, remember, inside the parentheses right here, this piece is the input. So take a look. Here's my input. D days. So this is P of D. Where am I going to write it? P of D. All right. So take a look. D. P of D. D is the days. So 215 days. 215 days. So 215 are the days. And what do I want to know? Remember, P is number of people. So 89 is the number of people. All right, so now I've got enough information in order for me to answer the question. All right, so out of 215 people, now I can't use that one, right? Because I'm saying 215 is days. So that one doesn't work. 89 people ordered a vegetarian luncheon. Okay, 89 people. Okay, that looks okay for 215 days in a row. No. That's not true. Look at D days after the new year, not in a row. So this one can't work. 89 people ordered a vegetarian lunch 215 days after the new year. Bingo! 215 days after the new year, 89 people. Ka-ching! Let's look at the last one just to make sure. 215 people. Nope, that's not right. Because 215 is the number of days. So it is not that one. So it is C, 89 people. And what I want you to be able to do is break it down. Don't start looking at your options. Break down what you know first and then apply your answer to what you already know. That's the best way to do it. All right, moving on. All right, so now we have another problem, and now we are given graphs. So let's first just read what this is about, and then we're going to break it down. All right, so we've got Brianna. Brianna rides her bike to school. She leaves her house and travels at a constant rate. Ooh, okay, we're going to go back to that. Constant rate for 4 minutes until she reaches a stop sign. She stops for a minute. Then she realizes she left her homework at home. She rides for 3 more minutes at a faster rate back home, where it takes her 1 minute to find her homework. Then she bikes straight to school. Which of these graphs best represent the situation? Okay, so before you start choosing, let's just think about it. She's riding her bike to school. So that means she leaves her house. So she's going to start at 0. All right, so this means starts at 0. All right, so I'm looking at each of the graphs. They all start at 0. Okay, cool. She travels at a constant rate for 4 minutes. So that means her line is going to be like this. All right. Now, the one thing you need to remember is that we have to read the graph that says 4 minutes. So her straight line, so right down here at the bottom, this needs to be 4. All right. I just wanted to tell you. All right. So then what else do we know? She stops for a minute. Stops means think about your drone. She stops. And this interval right here needs to be 1 minute. So if she rides at 4, she stops. So this interval right here has to be a minute. Then she realizes, and she left her homework at home. So think about when we were talking about those graphs. So going back home means she went down, right? That's going back home. Going back home. Then she rides for 3 more minutes at a faster rate. So this means this has got to be steeper because she's got to get home. And then she again found 1 minute to find her homework. So that means there's some kind of interval here for 1 minute. And then she rides straight to school. All right, so take a look. Which one is it? If I just look at what I drew and then I compare it to what I've got, I'm hoping that you see that it's graph A. So now, let's just think about this. This is where she goes at a constant rate. Constant. This is where she stops. This is where she goes back home. And this is where she goes to school. All right. So just make sure here, think about this. It can't be this one because she went that straight line back down to 0. That doesn't make sense. It can't be this one. Well, take a look. Travels at a constant rate. Stops, right? but then she keeps going. Well, no, she's going farther away, meaning looks like she's pedaling faster towards school. She didn't go back home. All right, and it's not this one because she never stopped. All right, so hopefully that helps. And again, it's reading the graph with really good clarity and detail. And again, breaking down the word problem to what it is you know first. Let's move on to the next one. All right, so now we've got another graph. And this time we are talking about domain and range. Okay, so remember, the one thing I want you to remember, domain is input and range is output. So let me make some notes on this slide. Okay, so you can see here that I inputted domain is the input, which is the time in seconds. So the time in seconds is down here at the bottom. All right, and the range is the output, and the output is the temperature right here. All right, so I just want you to look at the graph. I just want you to note that I've got time on the bottom, temperature on the left. All right, and if I look at the values, where does my graph start? My graph starts right here, right there. And where does my graph end? Right here. All right, so take a look. Is my graph starting right at 0? No, it's starting a little bit in from 0. So if I were to try to draw a dotted line, it did not start at 0. It starts about right there, right? And where does it end? Somewhere after 150, but it's not marked. So I'm going to have to do a little bit of guesstimating. All right, so let's now talk about the time, the range. So it starts from here, not there. Let me make sure so it starts from here and it goes all the way to here. All right, so what are those numbers? Well, it's not 0, so it's anywhere from let's just say greater than 0. So let's go from 1 all the way to maybe 175 or maybe even. I don't think it's 200, so let's just go 175 or thereabouts, all right? So now let's look at the side. Where does it, and I'm going to do this just so I can read this better. All right, so now I'm going to draw a line right there. So where was that at? That was at 100. So this is 100. This is my output. And, oh, take a look. That hit 0. So this is 0. So this is my range. So my range goes from 0 to 100, and my input, my domain, goes from 1 to 175 approximately. All right, so now let's take a look at it. Domain, 1 to 100. No, it goes more than 100. All right, so not this one. Domain, integers, 1 to 100. No, remember integers are positive and negative whole numbers. No, because time can be in fractional pieces. So it's not that one. Domain, 1 to 200. Ooh, that looks good because I said 175, so it could go greater than. Range, 1 to 100. 1 to 100. 1 to 100. Well, maybe, right? Maybe, because maybe I didn't read this very well. Oh, maybe, take a look. This didn't hit the very bottom, so yeah. So I'm going to look here. It's about right there. So, okay, I'm going to look at the last one. Integers, 1 to 200. No, remember integers are positive or negative whole numbers. No, because I could have fractional. So it's not that one. So it's this one right there. So that is how you read the graph. And you have to read the graph very, very carefully. All right, great job. let's move on and look at the next one. All right, more graphs. More graphs. Love this. All right, so we've got Jada filling her aquarium. The following graph shows the height of the water in the aquarium as a function of time in minutes. All right, let's verify. Height in centimeters. This is my output. Okay, input, time, minutes, perfect. All right, we're going to select all the statements that are true according to the graph. All right, so again, remember what I said. I love to read the graph. So we start at 0. Means no water in the tub or water in the aquarium. Constant rate right here. She's filling it up at a constant rate. Then she stops. This is where it stops. Then she keeps filling it again. Oh, maybe a little faster this time. Okay, then goes down. I'm going to have to pay attention to that. Did she do something there? All right, and then this is where it levels off. Remember, something stops. All right, so now let's also take a look at some other things. We know that this is the maximum point because it's the highest point. What's the lowest point? Right here. This is the minimum. This is also the starting point. That's critical. It starts at 0. All right. So now let's go ahead and take a look at my options. The maximum occurs at 5 minutes. So again, here's the max. I'm going to go all the way down, and definitely it occurs at 5 minutes. All right. It says it takes 30 minutes to fill the tank. No, because take a look. I don't see 30 along the bottom. So it's not that one. The vertical intercept shows the height of the water was 0 when Jade started. Take a look. Vertical right here. Right here. That's where she started. 0 when she started. All right. What else do we know? The function reaches its minimum. That minimum means the lowest at the horizontal intercept. So right here, this is the horizontal intercept. That is also the minimum point of the graph. Absolutely. The function has no minimum value. Nope, that's not true. The minimum value is in brown right there. So that is not true. There are multiple times that the graph is at its maximum. Nope, not true. Remember what I said. 1 maximum. All right, 1. All right, moving on. Hopefully that made more sense if we just kind of break it down. Next problem. All right, now we've got a party planner, and they're going to order pizzas for an upcoming party. Here's an equation. P is equal to N divided by 6, and that represents the function. The amount of pizzas to order is a function of the number of people who attend. All right, so P is the pizzas, the amount of pizzas. N is the number of people who attend. Number of people. So, if the party planner orders 7 pizzas. So, if I order 7 pizzas, how many people are attending? Well, that means P is 7 pizzas. So if I have 7 pizzas that I'm ordering, and this is the number of people, and that means, I get, what is the 6 then? Well, the 6 is the number of slices I get. So, if I order 7 pizzas, how many people are attending? How many people? So, how do I get n by itself? So, I'm hoping that you know, and I'm going to do it right here. If 7 is equal to n over 6, I am going to multiply both sides by 6. And that means that n is equal to 6 times 7, which is 42. All right, so let's do it another way. I want to know what number can I divide by 6 that'll give me 7. In other words, let's just use our number of 42. If I take 42 and divide it by 6, what is 42 divided by 6? It's 7. So, 7 pizzas. 7 pizzas. So, hopefully that made sense. And let's see, do I have any other problems? That's it. Congratulations, way to go. All right, awesome job. Go back through this as many times, especially that last problem if it gave you some trouble. All right, make sure you do this. Make sure you've done all that homework in Desmos, lesson 8/10. That is also critical. All right, good luck, you guys.